Good day, children. Today we are going to learn law of conservation of momentum. Before that, let us see one small activity that is with a test tube and cork experiment. In this activity, what did you observe? You observed that the test tube end was heated, wherein a cork was fixed with the test tube. After some time, you could see that the cork had been flew off from the test tube. So why this movement of cork had taken place? So here we see that there is an action and reaction forces acting on two different objects. Which law of Newton is working here? You could see that the backward motion of test tube is called recoil. You could see the test tube was moving in the backward position. And the velocity with which it was moving back is called recoil velocity. The moment it has flew off the cork from the test tube, you could see the test tube had went backward position. Similarly, in the example of gun also, the velocity with which the gun moves backward after firing a bullet is an example of recoil velocity. Recoil velocity of a gun is inversely proportional to its mass. So we say light gun recoil with large velocity and heavy gun will recoil with small velocity. In this scenario, we could see that if a speeding truck collides with a stationary car, what change would be seen in the speed, that is the velocity of truck and the car after collision? You will see that velocity of the truck decreases, but the velocity of the car will increase. This states increase in momentum of the car is accompanied by the decrease in the momentum of the truck. But there is no loss of momentum. Here you could see that the sum of the momenta of two objects before collision is equal to the sum of momenta after collision, provided there is no external unbalanced force acting on them. Now let us see a small PPT to explain you more on conservation of momentum. Here, what is momentum? Momentum of a body is defined as product of the mass and velocity. It is denoted with small p, that is equals to m into v. Now consider which of the following people have a greater momentum if the both are moving with the same velocity. Mass of the boy with the cycle is 70 kg and mass of the girl with cycle is 60 kg. So you could see that momentum of boy would be larger than the momentum of girl. This is caused because of the mass. The velocity is same. Momentum depends on mass. Greater the mass, greater is the momentum. Now here comes the law of conservation of momentum. Suppose you consider two balls A and B of mass MA and MB, which are traveling in the same direction along a straight line, but with different velocities, say UA and UB, respectively. And there are no other external unbalanced forces acting on them. If we consider velocity of the first object, that is UA, is more than the velocity of second object UB. So what happens? You could see velocity of the ball A and B before collision. It is MA, okay, and MB. So now you see velocities after collision, that is before collision they have dashed with each other, that is you could see MA and MB both were, and MA is with a faster velocity, MB is with less velocity. So they collide with each other. After collision, you could see that the velocity of mass of object A we determine with small va, and velocity of B, object B, we define with small vp. Here you shall notice that before collision and after collision, the change that you notice, the momentum of the ball A before collision is MAUA. Momentum of ball A after collision is MAVA. Ball A exerts some force on ball B. So we say that FAB. Rate of change of velocity momentum at this point is MAVA minus UA upon T. That is mass of the object A, final velocity of the object A minus initial velocity of object A upon the time taken. Similarly, we can also say that ball B is also exerting some force on ball A. So FBA is the rate of change of momentum of B, that is MB and VB minus UB upon T. That is mass of object B in product of final velocity of object B after collision minus initial velocity of object B, that is before collision, upon time taken. You will say that the Newton's third law of motion states that force AB exerted by ball A on ball B, that is the action, that is definitely equal to the reaction, that is the force FBA exerted on the ball B on ball A. That is, force FAB is equal to minus FBA. Why we have said is minus? Because you could see the another is a reaction which is acting towards the negative direction, that is opposite direction of the force applied by AB. So you say that MAVA minus UA upon T is equal to minus MBVB minus UB upon T. So we can simplify this, that time taken would be cancelled on both the sides. So you have the equation MA UA plus MB UB is equals to MA VA plus MB VB. So what do we notice here? That the total momentum of the system, that is two bodies, before collision is same as the total momentum after collision also. So this states the conservation of momentum. That is, the conservation of momentum is not lost anywhere. It remains the same. In this way, let us see more example. Let us see a small video about the law of conservation of momentum.
Law of conservation of momentum. When two or more bodies act upon one another, then in the absence of an external force, the total momentum of all bodies of system in a particular direction remains constant. This is known as law of conservation of momentum. Let two bodies, 1 and 2, have masses m1 and m2. Let their velocities be u1 and u2 before collision and v1 and v2 after collision. Initial momentum of body of mass m1 equals m1 u1. Initial momentum of body of mass m2 equals m2 u2. Total momentum before collision equals m1 u1 plus m2 u2. Final momentum of body of mass m1 equals m1 v1. Final momentum of body of mass m2 equals m2 v2. Total momentum after collision equals m1 v1 plus m2 v2. Body 1 exerts a force of action F12 on body 2. Body 2 exerts a force of reaction F21 on body 1. Suppose the collision lasts for t seconds. F12 equals rate of change of momentum of body 2 equals m2 multiplied by v2 minus u2 by t. F21 equals rate of change of momentum of body 1 equal to m1 multiplied by v1 minus u1 by t. Since reaction equals minus action, Newton's third law of motion, F21 equals minus F12. m1 multiplied by v1 minus u1 by t equals minus m2 multiplied by v2 minus u2 by t. m1 v1 minus m1 u1 equals minus m2 v2 plus m2 u2. According to law of conservation of momentum, m1 v1 plus m2 v2 equals m1 u1 plus m2 u2. Momentum of a system after collision equals momentum of a system before collision. Example, gun and bullet. Initial momentum of bullet and cannon is 0. When the cannon is fired, bullet acquires a momentum mv. Cannon moves in the backward direction with a momentum equal to that of the bullet. To obey the law of conservation of momentum, final momentum of bullet and cannon should be 0. That is, final momentum of bullet and cannon equals mv plus mv dash equals 0. mv dash equals negative mv. v dash equals negative mv by capital M, where small m is the mass of bullet, capital M is the mass of cannon, v dash is the velocity of cannon, and v is the velocity of the bullet.
So in this way, we have learned what is the law of conservation of momentum. Now, let us see a few numericals based on laws of motion. Here is a question, that is, a bullet of mass 28 grams is fired from a pistol of mass 2.8 kg at a velocity of 200 meters per second. Calculate the recoil velocity of the pistol. So first thing is we shall note what are the given details. Mass of the bullet, I say like M1 is 28 grams. We shall convert that into kg, 0.028 kilograms. Mass of pistol is M2, that is 2.8 kg. Initial velocity of bullet is 0 as well. Initial velocity of pistol is also 0. Final velocity of pistol is given as 200 meters per second of bullet. We need to find what is the final velocity of pistol, that is recoil velocity of pistol. So according to the law of conservation of momentum, we shall substitute m1u1 plus m2u2 is equals to m1v1 plus m2v2. So we substitute 0.028 into 0 plus 2.8 into 0 is equals to 0.028 into 200 plus 2.8 into V2. As we get the left hand side all 0, so 0 is equals to 5.6 plus 2.8 into V2. So V2 will be definitely equal to minus 5.6 upon 2.8, that results to minus 2 meter per second. Now the question arises, why minus sign? Since it is a recoil velocity where the pistol is moving in the opposite direction when the bullet is being fired in the forward direction. So hence it is very important to note the sign also, that is a negative sign for the recoil velocity. Let us see one more example where you consider two spherical balls A and B. Say mass A, that is the object A's mass is 2 kg, second ball it is 5 kg, are moving with velocity 4 meter per second and 2 meter per second. That is the first object A is 4 meter per second and second B is 2 meter per second. They collide, and after collision ball A moves backwards and velocity of 1.5 meter per second. So backward means definitely we shall make a note that it is negative. Now let us find the final velocity of ball B. So MA is equals to 2 kg, MB is 5 kg, UA initial velocity of ball A 4 meter per second, UB is 2 meter per second, VA as we discussed earlier it should be negative, so minus 1.5 meter per second since the ball is moving in the backward direction. We need to find VB. Same we shall formulate in the law of conservation of momentum. MAUA plus MBUB is equals to MAVA plus MBVB. Substituting the values, we have 2 into 4 plus 5 into 2 is equals to 2 into minus 1.5 plus 5 into VB. We have on the left hand side the sum as 18 is equals to minus 3 plus 5 VB. We take over 3 on the other side, so minus 3 will become plus 2.1, that is 21. 18 plus 3 results to 21 equals to 5 VB. So VB, that is the velocity, final velocity of ball B is 4.2 meter per second. You could see initial velocity of that ball B was 2 meter per second, and later it has turned up to be 4.2 meter per second. So in this way, we have learned today the conservation of momentum and numericals based on conservation of momentum. Thank you, children. Good day.